So next, if we look at our small cell scene, what I'm showing now is wireless InSite in this view of this scenario in Roslyn, Virginia, an urban small cell in which we've placed 16 devices, one of them moving along a mobile route down the street and around a corner. We have also placed a base station, a Massive MIMO base station in the bottom middle. If we zoom in on this, we can see that this base station is actually an array of 8x8 array of antenna elements, and it actually has cross-pole elements as well, making a total of 128 elements between the vertically and horizontally polarized copies of the antenna. Wireless InSite provides some simple techniques once we've set up a scene like this to set up our array antenna. We can simply create a new antenna. And then we use an antenna array builder for the MIMO antenna. Now in this case, we will choose to create a half-wave dipole and create an array of these dipoles just to show how we went about creating our antenna for the simulation. So wireless InSite does not restrict anything about how the antennas in the array can be placed. They can be in non-uniform positions, but it does provide a simple mechanism that allows us to quickly build up an array. So in this case, we will select the ability to place our wavelengths as a function of spacing, our antennas, I mean. We place each of the antennas with a spacing of half a wavelength, and to replicate what we did in our simulations, we will create an 8x8 array. And now we can see that we have now created an array of vertical dipoles at each of these 64 positions. Now in the case of our simulation, we also wanted to have another 64 cross-polarized elements. So we bring up our MIMO array builder again, and we can go through the same steps to create our horizontal elements. The one difference this time is that we notice that our array is facing down the x-axis of this coordinate system, so we want to rotate the antenna. And now we can see we've got a horizontally polarized dipole antenna pattern, and we've added this to our array as well. So we now have 64 elements that are vertically polarized as before, and we have another 64 elements in the same positions that are horizontally polarized. In an actual system, we might have patch antennas or some other type of antenna type that achieves this same goal. So once we've created the antenna, we can then perform simulations.